Imagine going into space. You've got your kit, you're blasted into darkness, you're ready to discover the unknown, to boldly go where no one's gone before, but then your equipment doesn't quite fit the task required. How can you prepare for that? Deliveroo don't seem to deliver to space, so this is a reality that space engineers and robotic experts are trying to face every day.
Well, now, researchers from Yale think they've got the answer. They've developed something called the Skin, which is a sheet of material that can animate everyday objects and turn them into robots. Izzy Clark spoke to the study's author, Joran Booth.
One of the problems with traditional robots is that they're often quite heavy, they take up a lot of space, and it's very expensive to take them into space. So my advisor came up with the idea of using a flat, soft skin that could wrap around any soft body and turn that into a robot.
So how did you make this?
We've made a number of different prototypes, but they all have a very similar body plan. So they'll have some sort of substrate. It may be fabric or it may be a sheet of silicone rubber. Then we'll put some kind of artificial muscle on it and then a sensor on it, and then we'll bind them together. Then we basically put something on top to make it look pretty, and then we put it on the soft objects to make them into robots. And by being able to wrap around in any direction that you want or in any combination that you want, you can get a very wide range of motions.
So I'm imagining a sheet of material. It's got all of these muscle-like structures on it. How does it work, and what sort of motions are we talking about here?
The robotic skin relies on the actuators that I mentioned earlier, these artificial muscles inside of it. And there's different artificials that do different things. In the concept that we showed in the paper, we used a kind of artificial muscle that just contracts, like the normal muscles in your arm or your legs. If you position those muscles different ways on different soft bodies, you'll get different motions. So imagine that you had a foam tube or something like that. If you make the artificial muscle go around the outside of that, so it wraps all the way around it like a ring, it's going to contract it and it's going to pinch it when you turn that muscle on. Alternately, if you have it running up along the side of the soft tube, it's going to cause the tube to bend. And so with that, we can get complex motion by just turning the skin.
So is it that you could literally have this skin, apply it to one object and it works in one sort of direction, and you can literally take that same skin and apply it to a different object and have it do something entirely different?
Yes, it depends a lot on what you put it on, but absolutely. You could take the same skin, put it on one object, and then the next object you put it on, you may be oriented a little bit differently, and you get that object to move as well.
How does it get its power, though? How is it powered to enable all of these different types of motions?
That's a great question. In the paper, we actually show two different kinds of artificial muscles. One is a wire. If you have it as a spring, if you heat it, it'll shorten. The one that we use more commonly is a pneumatic muscle. So that means that it's this mesh that has a balloon inside of it. And then when you fill that with air, it will shorten. And so we basically have an air supply off of the robot that we use to power the robot.
How much could we use a device like this? Is it purely for, say, space exploration because you've been partnered with NASA to make this?
That's right. And we're still looking for new applications, things like create a rover that can roll around on the surface of Mars and find things, including a gripper and having a robotic arm that you could make on the fly with the same set of robotic skins. But also the robotic skins may be used to do things like a wearable device that can detect the posture of the person who has a shirt with these robotic skins on it.
Sorry, did you say that this robot can fix someone's posture?
So I've actually worn this thing, and yes, it can detect if you're slouching, but from experience, it's very annoying to have it remind you incessantly, you're slouching, get up, get up.
So Big Brother won't be so much as looking over your shoulder as sitting on it in future. That was Joran Booth from Yale University, who was speaking with Izzy Clark, and the study just came out in Science Robotics.